Alright, let's get started. K empty slots. Okay, so there is a garden with n slots. In each slot there is a flower. The n flowers will bloom one by one in n days. In each day there will be exactly one flower blooming and it will be in the status of blooming since then. Okay, so the flower won't perish. Given a array of flowers consists of number from 1 to n. Each number in the array represents the place where the flower will open in that day. For example, flowers at the index of I equals to x means that the unique flower that blooms at day 1 will be at position x, where I and x will be in the range from 1 to n. So the ranges of I and x will be the same. Also, given an integer k, you need to output in which day there exist two flowers in the status of blooming, and also the number of flowers between them is k, and these flowers are not blooming. So we need to find a gap in between two flowers whose number is the same as k. Okay, if there isn't a such day, I'll put -1. Okay, so let's take a look at the examples. The first example is, so we have input 1, 3, 2. So on the first day we have flower at position 1, and the second day we have flower at position 3, and the third day we have another one at 2. So k is 1 and output is 2. So on the second day, the first and the third flower have become blooming. That makes sense because the difference between 1 and 3 is 1. So position 1 and position 3, there is one empty slot. Now the second example, we have 1, 2, 3, and k is 1. So in this case, it's -1 because in the 3 consecutive days, we don't have any empty slots left between the flowers, the blooming flowers. Okay, so this is apparently a array problem, and the first solution I would think of is using binary insertion. So binary tree insertion. So we can create a new array list, and then while we iterate through the flowers array, we are going to insert the position into this new array list. So for example, in this case, we have 1, 3, 2, and we're going to create a new array list. And then when we have 1, we're going to insert it in the first position, and then we have 3, and the next one we have 3. So we're going to insert 3 into the new array, and then we're going to check if the difference between its adjacent elements is equal to k. So in this case, we have 3. We insert 3. 3 is bigger than 1, so it's inserted right behind 1. And we compare the difference between 1 and 3, which is 2 and 1, right? So the difference between 1 and 3 is equal to k plus 1. So this is what we want. So we want to return 2. In this case, in the second example, we have 1, 2, 3. So in new array, we're going to insert 1, 2, no, 3, no. So this solution will probably take n log n, big O n log n, because for every element in the flowers array, we have to do a binary search, which is log n. So can we do better? Yes, so right now the flowers array. Now there's one thing. So we have to, at the best, we have to do big O of n because we have to at least iterate through the flowers array. So if we invert the index and the value of flowers array and then convert it to an array that is represented by days, number of days, instead of the position, the flowers position. So in this case, I is number of days, and x is the position. So what if we flip it around and we have x as position, we have I as position and x as days. So we have a very visual representation. In this case, what I meant was we can have, say, array called positions, and the size of the array will be equal to the size of flowers array. Okay, now what do we want to do with this? So since this is a visual physical representation of the slats, so we need to create a subarray whose length is k, right? Because so first of all, we are going to create. We're going to populate this new positions array. So we're going to start from 0 and I less than flowers dot length I plus plus. So for every position, since what we want is the position of the flowers, and in this case, the positions of the flowers is not zero base. So we want them to be zero base. And then the days, number of days. So days is I plus 1, because days, the expected output needs to be not 1 based, but the input provided, the days of the input provided is 0 based. So this is why we're adding 1 to I. Now, after we have populated these positions, we need to set up the boundary. We need to set up the boundaries of the subarray. So we have left, and left is 0, and right is gonna be. So the right is going to be left. Well, actually, is k plus 1. Why is that? Because k plus 1. Because with k is 1, we want the right to be 1 more than left plus k. Okay, and then we have result is equal to integer max value. So the result is the final day that we want, right? The final day that we want. if we're comparing the boundaries, we are not sure if the day on the left index is smaller or larger than the day on the right index. So we have to compare the left boundary and the right boundary and then assign it to result. So for I is equal to 0, I, well, right less than positions length, and I plus plus. So if the day at the current index is larger than the boundaries, then that's what we want, because that means before this day has come, the slots in between the boundaries are empty. Okay, so if positions I is larger than positions left and positions, I can't spell, larger than position right. Okay, if they are more than, if the day at this I index is larger than left and right, then this is what we want. We continue, we do nothing. But if I is equal to right, which means we have reached the boundary, the right boundary. So in this case, we're going to compare the results because this is the final result we want. So the result is going to be math minimum results and then math. So in this case, we want the bigger day because we won't have, if we choose the smaller, then we'll only have 2 blooming flowers on the bigger day, after the bigger day, right? So positions left and positions right. Okay, so now after that we need to renew the indices, the boundaries. So left is going to be I, and right is going to I plus k plus 1. Alright, so if left is 1 and right is 3 and k is 1, so I plus 1 plus k plus 1. Okay, that's correct. Okay, now, so after we need to return the result. So first of all, if the result is still equal to max value, which means we haven't met any day. We haven't got the result we want. Right? We didn't get any results, so we're going to return -1. And but if it's not, we're going to return results. Okay. Okay. So this is pretty straightforward, and so this is using a sliding window, and I think the tricky part of this is we are converting the flowers array into a positions array. So I think that's the key point the critical point, the critical part, of this question. All right, let's test it. So let me see. So for every element in the flower array, we're going to assign this is the position, right? So at this position, we will have day I plus 1. Okay, that makes sense. And we have result and left and right, and it's less than right is less than this. Okay, I think we're good. Let's test it. 2 and 2. Okay, looks good. Whew. Okay, great. Accepted. Perfect. Yeah. So, like I said, the critical point of this question is, first we need to convert the array. Now, this is the conversion. So, convert the representation. In this case, by the way, how many minutes? Oh, we only used 17 minutes. Okay, so anyways, so 2 points. One is convert flowers array into positions array to have a visual representation of the slots. And the second is to remember that we are comparing this. This is the comparison. So we are comparing the slot in between the boundary with the boundaries. Okay, anyways, I guess that's pretty much it, and I'll see you in the next question. Happy coding. See you next time.